Hi everyone, I hope you all are doing well. In my previous video, we learned about multiple, factor, LCM and methods to find LCM. So based on that, here is a question for you. Solve it and answer me in the comment section. Let's take an example. Here, Mahi has two pieces of cloth of two measurements. She wants to cut both the pieces into equal measurements. That means the measurement should be common. What we have to use to find the common width or measurement of both the pieces? We have to find H.C.F. So to find any common value or thing, we have to find H.C.F. Let's learn about H.C.F in detail. Let's take two numbers, 4 and 8. Let's write the factors of 4. 1, 2, 4 are the factors of 4. 1, 2, 4, 8 are the factors of 8. The common factors of 4 and 8 are 1, 2, 4. Among these three numbers, 4 is the highest common factor of 4 and 8. For smaller numbers like 4, 8, it is easy to find the highest common factor. For larger numbers like 5, 513, 783, it is not easy to find the highest common factor. So in this case, we use highest common factor by using division method or prime factorization method. Let's learn how to find the HCF by division method. Let's take two numbers, 120 and 288. First, we have to divide the greater number by the smaller number. So we take 288 in the place of dividend and 120 in the place of divisor. 122 is 240. We get 48 as the remainder. Next, we have to take the divisor in the place of dividend. And we have to divide 120 by 48. 48 2s are 96. We get 24 as remainder. Again, we have to continue the division. We have to take 48 in the place of dividend and we have to divide it by 24. So we get 24 2s are 48. We have to continue the process till we get 0 as our remainder. So here 24 is the highest common factor of 120 and 288. So the last divisor is the required HCF of the given numbers. Here 24 is the last divisor. So HCF of 120 and 288 is 24. In this way, we find the HCF of two or more numbers by using this method. Let's learn how to find HCF of three numbers by division method. Let's take three numbers, 136, 170, 255. Here we have to take the two numbers. We have to divide the greatest number by the smallest number. First we take 170 and 136. write 170 in the place of dividend and 136 in the place of divisor. 136 into 1, 136. Now we have to write 136 in the place of dividend. We have to check whether 136 comes in 34 table or not. 34 into 4 is 136. So we have to continue the process till we come 0 in the remainder. Now 34 is the highest common factor of 136 and 170. Now the remaining number is 255. Now we have to divide 255 by 34. Take 255 in the place of dividend and 34 in the place of divisor. Here 34 is the H.C.F of 136 and 170. So we are dividing 255 by 34. We have to check whether 255 comes in the table of 34 or not. 34 into 7 we get 238. Now we have to write 34 in the place of dividend. We know 17 into 2 is 34. So 17 is the H.C.F. You may have doubt whether 34 is the H.C.F or 17 is the H.C.F. The last divisor is the required H.C.F of the given number. Here 17 is the last divisor. So H.C.F of 136, 170 and 255 is 17 because it is the last divisor. So let's learn how to find HCF by using prime factorization method. Let's take two numbers 120 and 288. Here we have to find the prime factorization of each of the given numbers. First we find the prime factorization of 120. Here we have to use only the prime number to divide. 2 into 60, 120. 2 into 30, 60. 2 into 50, 30. If in two table we don't take 15, so we take 3. 3 into 5, 15. As in my previous video already told, in prime factorization method, we have to end this process till we get the prime number at the end. So 120 is equals to 2 into 2 into 2 into 3 into 5. Now find the prime factorization of 288. 2 into 144 is 288. 2 into 72 is 144. 2 into 36 is 72. 2 into 80, 36. 2 into 9, 80. Here we write, here we take 3. 3 into 3, 9. So 288 is equals to 2 into 2 into 2 into 2 into 3 into 3. So let's compare 120 and 288. 120 is equals to 2 into 2 into 2 into 3 into 5. 288 is equals to 2 into 2 into 2 into 2's are common, and these two 2's are common, and these two 2's are common, and this 3 and this 3 is common. In these two 2's we take only one 2. Here also we take only one 2. Here also we do the same. In these two 3's we take one 3. So 2's are
4. 4 into 2, 8. 8 into 3, 24. So 24 is the HCF of 120 and 288. We can also write the prime factors in exponential form. Why we use exponential form? Because if we take big numbers, we can't write in this format. It is difficult to write. So we take exponential form. 120 is equals to 2 into 2 into 3 into 5. We can write it as 2 cube into 3 into 5. Similarly, in 288, we can write, here there are 5 2's, to the power of 5 into 3 square. So we have to take the least power of each common prime factor. Here the least power is 2 cube. And here the least power is 3 to the power of 1. As we don't have 5 here, so we ignore it. So the HCF of 120 and 288 is 2 to the power of 3 into 3. 2 to the power of 3 is 8. 8 into 3 is 24. Either in this method or in this method, we get the same HCF. Till now, we learned how to find LCM and HCF of whole numbers. Now we'll learn how to find LCM and HCF of fractions. Let's take some fractions. Let's learn how to find the LCM of fractions. We take 1 by 3, 5 by 6, 2 by 9, and 4 by 27. We have to find the LCM of these fractions. To find the LCM of fractions, we use this formula. We have to first find the LCM of numerators and then we have to find the HCF of denominators. Here the LCM of numerators 1, 5, 2, 4 is 20. We can find the LCM of these numbers by using any prime factorization method or division method. And we have to find the HCF of denominators. That is HCF of 3, 6, 9, 27. If we observe, we can easily say that 3 is the highest common factor in all these terms. So here 3 is the HCF. So our required LCM is 20 by 3. 20 by 3 is the LCM of 1 by 3, 5 by 6, 2 by 9 and 4 by 27. Let's learn how to find the HCF of fractions. Here is the formula used to find the HCF of fractions. First we have to find the HCF of numerators and then we have to find the LCM of denominators and then we have to divide it. If we see this, we can easily find the HCF. Here in 1, 5, 2, 4, 1 is the highest common factor. The HCF of numerators is 1. And now we have to find the LCM of 3, 6, 9, 27. And the LCM of 3, 6, 9, 27 is 54. So the HCF of these fractions is 1 by 54. In this way, we find the LCM or HCF of fractions.
I hope you understand what we discussed in this video. The question which is asked in the starting of the video should be answered in my next video. Till then, take care. Stay home, stay